Hello everyone. This video presents use cases of the handheld LiDAR scanners S1 and the P2 model developed by FJD Dynamics. My name is Kawazu Uchida, and I am a professor at Tokyo Polytechnic University. Since the launch of the Trion S1, my laboratory has adopted and utilized a variety of systems, including the S1 RGB camera, an extension pole, a vehicle-mounted MMS, mobile mapping system, unit, and the V10i as an RTK-GNSS solution, across a wide range of environments. First, I will introduce several examples of these applications, followed by use cases of the recently released P2 model. In particular, these devices function as highly effective 3D scanners in the various situations I will describe. They have become a strong driving force in my laboratory's research on creating archives of historical structures and natural formations. As you are aware, LiDAR typically emits laser light at a wavelength of 905 nanometers in the near-infrared range. The S1 can rapidly acquire 3D point cloud data within a range of approximately 100 meters, while the P2 can do so within a range of about 40 meters. As an introduction, let's take a look at the S1 and P2 laser beams using a special infrared camera. As you can see, the laser beams are scanning the surrounding area in all directions. I recorded this footage because I thought that visualizing the scanning pattern would make it easier to understand how to achieve better scanning performance. First, the initial example is an application to a historical building using an extension pole and RTK-GNSS. The extension pole was used to capture the roof surface, tile surface, as well as to understand the structural condition of the attic. RTK-GNSS was used to suppress slight drift or misalignment in the point cloud and SLAM. In this way, by using an extension pole equipped with an S1 scanner, it is possible to accurately capture the detailed structure of the attic space. Furthermore, by using the processing software Trion Model, the dimensions of each component, as well as the roof pitch, can be precisely estimated. As a second example, I would like to introduce the FJD Trion S1 with MMS, mobile mapping system. This is a loop road located in Kawazu, Japan. Some parts of this video were used last year, but it has been newly edited for this presentation. In this way, even during vehicle movement, if RTK correction is applied, it is possible to obtain clean SLAM data even when the IMU, inertial measurement unit, is subjected to significant motion disturbances. From the third example onward, I would like to explain a case study using the recently released compact and lightweight Trion P2. As a verification site, I will introduce an example of a LiDAR scan of the Enoshima lighthouse, the Sea Candle, located in Fujisawa City, Japan. With the new P2 and S2 models, in addition to improvements in LiDAR SLAM and IMU performance, the built-in stereo cameras mounted on both sides enable visual SLAM. As a result, they can achieve SLAM results with extremely minimal twisting or drift. For this occasion, we were specially allowed to enter the lighthouse's lantern room, where we scanned the entire interior. The colored point cloud and the scanning path are shown separately. Once a 3D point cloud has been generated, the viewpoint, that is, the position of the virtual camera, can be freely placed anywhere within the scene. While this functionality is available in many 3D point cloud software packages, Trion Model offers an additional feature. It can automatically generate a fly-through video in which the camera moves along the actual scanning trajectory. Here is an example. FJD Trion model has seen significant technological advancements in recent years. One of the most notable is the implementation of 3D Gaussian Splatting, 3DGS, which enables the generation of highly realistic, photorealistic 3D scenes. First, I will show the results produced with version 207, released a few months ago, and then introduce the latest improvements in version 208. Kawazu Sea Cave is a naturally formed sea cave located on the Izu Peninsula. Over time, the cave ceiling collapsed, creating a large circular skylight that allows sunlight to stream into the cave, producing a spectacular natural scene. It is also well known for its heart-shaped outline when viewed from above, making it one of Izu's most popular scenic attractions. Finally, we used the compact and lightweight Trion P2 to capture the Kawazu cave. The following shows the results processed with TrionModel208. In the previous 3 FD point clouds, the crucial ocean region could not be reconstructed. However, in 3DGS mode, it is clear that the scene was captured beautifully, including its texture. The technological advances over the past year or even just the past few months have been remarkable. There are still many outstanding features that we have not been able to fully introduce, such as the global coordinate transformation and cross-sectional slicing functions. In addition, the system offers a forestry mode with a wide range of advanced capabilities, including tree classification and numbering, automatic detection of trunk diameter, dBH, tree height, and other parameters. As one example, we present here a demonstration video showing a simple X, Y, and Z slicing process. In forestry mode, the system first extracts the ground from the reconstructed 3D point cloud. It then analyzes the trunks and branches growing from the ground and assigns a unique number to each individual tree. Each tree can be selected individually to display its attributes, such as trunk diameter, dBH, and height, or the information can be exported collectively as a table. As part of our laboratory's activities, at the Enoshima Art Festival 2026, we were able to create scanned models of caves and the lighthouse based on 3D data acquired with Trion S1 and P2. These were integrated into a model of the entire Enoshima area and exhibited for 2 months at the Sea Candle observation deck. Together with young students in our university laboratory, we work every day to master these valuable technologies and capabilities using FJ Dynamics products. Capture reality. Create the future. Thank you very much for your kind attention.